Assalamualaikum and hi. For this week, we are still in our introduction and basic concept of thermodynamics topics for part 2. So on today's video, we are going to learn the definition of property here, state and process, and how you can distinguish between these three terms. So we start first with the state. So what is state? So state is the condition of a system at any instant of time. The state at a given instant of time is described by the properties of the system. Meaning here, without knowing the properties of a system, you cannot know the state, or in this case, the condition of a system. A property is any quantity whose numerical value depends on the state but not the history of the system. So the example of the properties that we have learned previously in our lecture is like temperature, the energy, the volume, the pressure, and also others. The value of property is determined in principle by some type of physical operation or test. Properties are considered to be either extensive or intensive. So this is the criteria to differentiate extensive and intensive properties. So these are the properties in a system that commonly can be understood, which is we have here a mass, volume, temperature, pressure, and density. So which one are of those properties? Which one is the extensive and intensive properties? So we have mass and volume can be considered as extensive properties. For temperature, pressure, and density, it can be classified as intensive properties. So what are these extensive and intensive properties? What are the difference of these extensive and intensive properties? As illustrated in this figure, we have an amount of matter. This matter is a barbell with the weight plates. Okay, so the total weight for this barbell with the weight plates is 25 kilogram. So we have an amount of matter that is uniform in temperature, which is at ambient temperature or room temperature at 20 degrees Celsius. And another is composed of several parts. Several parts before the barbell and the weight plates are being combined together. So consider the mass properties. The mass of the whole at this figure A is the sum of the masses of the parts in B. And this is same for volume properties. So whatever total of weight of this figure in A is actually same with all the parts in this figure B. The overall volume at A is also the sum of the volumes of the parts in B. So we can call that as mass and volume of figure A is the same with the several parts of this matter in figure B. However, on contrary, the temperature of the whole is not the sum of the temperatures of the parts. It is the same for each part. For example, the total temperature of this barbell and weight plate placed in the room temperature is 20 degrees Celsius. Okay, the total. But for B, it's not the same. Okay, the temperature for all of the several parts before the barbell and the weight plates are being assembled, the temperature is different. Okay, might be this weight plate is 20 degrees Celsius, this is 20 degrees Celsius, and another weight plate is 20 degrees Celsius. So the temperature is not the same between these two parts. It is opposite to the mass and volume. So here are the definition for extensive and intensive properties. For extensive, properties depend on the size or extent of the system, while for intensive, the properties are independent of the size or extent of the system. So, like the figure that we learned just now about the amount of matter, figure A and figure B, which is the whole assembled barbell and the weight plates. So the extensive here, properties depend on the size or extent of the system, like its mass and volume is the same with the several parts when the barbell and the weight plates are not being assembled yet. But for properties like temperature properties like in the figure B, several parts of the weight plates and the barbell are independent of the size or extent of the system. So like I said, the figure A, the assembled barbell and the weight plates placed in a room temperature is 20 degrees Celsius, but the temperature for the several parts should or could not be the same like in figure A. The characteristics of the extensive properties, it is additive, which means its value for the whole system is equal to the sum of the values for its parts. So other than volume, mass, we also have examples of extensive properties is the energy and entropy. So the states are identical if and only if the properties of the two states are identical. When any property of a system changes in value, there is a change in state and the system is said to undergo a process. So you should now clear on the definition, the term used between property, state, and process. Now let's go to the next topic, which is phase and pure substance. First, we try to understand the term phase. So this term refers to a quantity of matter that is homogeneous throughout in both chemical composition and physical structure. So the homogeneity in physical structure means that the matter is all solid or all liquid or all vapor or equivalently all gas. A system can contain one or more phases. When more than one phase is present, the phases are separated by phase boundaries. For gases, so look at here, for example like gases, say we have oxygen and nitrogen. Those two can be mixed in any proportion to form a single phase. For liquids, Certain liquids such as alcohol and water can be mixed to form a single liquid phase. However, liquids such as oil and water, which are not miscible, meaning they cannot be mixed, can be formed in two liquid phases. So when more than one phase is present, the phases are separated by phase boundaries. Now, for pure substance, a pure substance is one that is uniform and invariable in chemical composition. A pure substance can exist in more than one phase, but its chemical composition must be the same in each phase. For instance, if you have a liquid water and water vapor form a system with two phases, the system can be regarded as a pure substance because each phase has the same composition, which is water. So the nature of phases that coexist in equilibrium is addressed by the phase rule. That's all for this video, and we'll see each other again soon.